All right, let's take a look at Chapter 4, Scatter Plots and Correlation. In Chapter 4, we cover explanatory and response variables, displaying relationships in scatter plots, interpreting scatter plots, adding categorical variables to scatter plots, measuring the linear association through correlation, and facts about correlation. Explanatory and response variables. A response variable measures an outcome of a study. An explanatory variable may explain or influence changes in a response variable. So outcome is the y-axis. The most useful graph for displaying the relationship between two quantitative variables is a scatter plot. A scatter plot shows the relationship between two quantitative variables measured on the same individuals. The value of one variable appears on the horizontal axis, and the values of the other variable appear on the vertical axis. Each individual in the data appears as the point in the plot fixed by the values of both variables for that individual. Always plot the explanatory variable, if there is one, on the horizontal axis of the scatter plot. As a reminder, we usually call the explanatory variable x and the response variable y. If there is no explanatory response distinction, either variable can go on the horizontal axis. Making the scatter plot in the context of our four-step process. State, plan, solve, and conclude. The research question of interest as a statement of the association between two variables in your data is the state step. The solution of your problem by plotting the variables according to the guidelines of the previous slide is the plan. Examine the scatter plot, taking note of any relationship present is how we solve, and we will explore the conclude step later. So here, make a scatter plot of the relationship between body weight and backpack weight for a group of hikers. We have body weight on the x-axis, we have backpack weight on the y-axis, and you can see the dot at 120,26 is the first individual in this chart. Interpreting scatter plots. To interpret a scatter plot, follow the basic strategy of data analysis from Chapter 1 and 2. Look for patterns and important departures from those patterns. As in any graph of data, look for an overall pattern and for striking deviations from that pattern. You can describe the overall pattern of a scatter plot by the direction, form, and strength of the relationship. An important kind of departure is an outlier, an individual value that falls outside the overall pattern of the relationship. The direction of the association is either positive or negative. Two variables are positively associated when above average values of one tend to accompany above average values of the other, and below average values also tend to occur together. Two variables are negatively associated when above average values of one tend to accompany below average values of the other, and vice versa. Adding categorical variables. Consider the relationship between mean SAT verbal score and percent of high school grads taking SAT for each state. So we have a scatter plot. And to add a categorical variable, use a different plot symbol or color for each category. The mean SAT mathematics scores and percents of high school graduates who take the test for only the Midwest are plotted in blue, and the Northwest are plotted in red. The blue is in the shape of a circle, the red is in the shape of a square, because not everyone can see the color difference. Measuring the linear association, a scatter plot displays the strength, direction, and form of the relationship between two quantitative variables. The correlation R measures the strength of the linear relationship between two quantitative variables. We have this formula where we have each deviation in the x's divided by the standard deviation times each deviation in the y's divided by the standard deviation multiplied onto each other, and for each data point summed, right? So each data point is calculated and then summed, and then we take the average using the degree of freedom in -1. Correlation makes no distinction between explanatory and response variables. R has no units and does not change when we change the units of measurements of X, Y, or both. Positive R indicates positive association between the variables, and negative R indicates negative association. The correlation R is always a number between -1 and 1. Correlation requires that both variables be quantitative. Correlation does not describe curved relationships between variables, no matter how strong the relationship is. Correlation is not resistant. R is strongly affected by a few outlying observations. Correlation is not a complete summary of two variable data.